Now this is the equivalent decimal. What is the meaning of equivalent? Equivalent means equal values. Equivalent, equal values. Okay, the meaning is equal values. Now come to the point. Equal values, how you will write it? Equal values, suppose if the question is given 2.3, 2.30, 2.300, right? Now tell me which type of decimal is this? We have learned in the last class like decimals and unlike decimal. Can you tell me which type of decimal is this? Unlike, right? It looks like unlike. Now you will understand here how you can convert it unlike decimal to the like decimal. Okay, and because the value is also same, value is also same, because they are all equal to the fraction. How? When you convert it into the fractions, these numbers, so how you will convert it into the fraction? 23/10. You will converting into the fraction is like this. This you will be converting into the decimal, then you will get this.
So you can.
Once you will wait. Now check, this 0 we can be reduced with this 0 easily. These two zeros we can simplify here. The result you can see it here, 23/10, 23/10, 23/10. So what is the conclusion here?
And also, you can also do like you said, the 0 after the decimal point or before, it doesn't matter.
Yes.
You need to look at the number.
So you can say that, in other words, adding 0 to the extreme right of the fractional part or decimal part. If you add, see, 2.3 is the base decimal. If you add 1 0 in this, if you add 2 0, if you add 3 0, extreme right of the decimal part, then the decimal number does not change the number. So you can easily do it. So they are all equal when converting the fractions into decimal or decimal into fractions. Easily you can convert it. So basically, like decimals may or may not have the same number of digits to the left of the decimals, but the decimal numbers like this are equivalent decimal, but they are unlike decimal. But what we call it here? Unlike decimal, because there is a number of decimal digits are not same. Here is 1 digit, here is 2 digit, here is 3 digits. So we call it unlike decimal, but the values are same in all the decimals. Okay? Yeah. So the concept is here, suffixing or any extra 0 written as the end of the decimal number does not change its value. See, does not change its value. Okay, it's same like this. So 2.3 is same like 2.30. It's same like 2.300. Even if you add more 0, then again it's a same. Okay, understood here? So easily you can find the equivalent decimals here. So when you compare it, you will get it. And should I give more example based on this?
No.
Okay, understood, no? So if I given the other example, suppose if I given the other example like 0.4, 0.4, 0.40, 0.400. Tell me, these all are the equivalent decimals or which type of decimal?
They're unlike and they're equal.
Yes, correct. Okay, understood?
Yeah.
Same 2.5, 2.500, 2.5000 and 2.50. Now check all four. Is this equivalent decimal or not?
Yes.
Right? So easily, so it's free. Extreme right of the decimal part of the decimal number does not change the number if you are adding 0 to the extreme right. Okay, topic is converting unlike decimals to like decimals. Okay, we know that adding 0 to the extreme right of the decimal part does not change the value of the decimal number, right? As we have discussed in the equivalent decimals, right? Therefore, unlike decimal can be converted into the like decimal by adding 0 to the extreme right of the decimal part. Now come to the example. Suppose I am writing 1 unlike decimal. 1.1. The next is 1.12 and the next is 1.235. Now check how many decimal places in these three decimal number. Here is 1 place, here is 2, here is 3, right? Now check the maximum number of places. So the maximum number is 3, right? As you can see in the question, right? 1.1, here is 1 decimal place, here is 2 decimal place, here is 3 decimal place. But this is the unlike decimal, right? What is called unlike decimal. Now unlike decimal, when we need to convert it into the like, as you know it in the equivalent, if you adding 0 to the extreme right of the decimal part does not change the value of the decimal. So because here is 3, so we'll make it all the decimal places is 3. 100. Now it's become 3. 1.12, it's 2 digits. We'll add it 0 here, and this is already in the 3 digits. Now you can see it here. Now it's become 3. It's become 3. It's become 3. All are 3. So we can call it a like decimal. Understood now? Any confusion? So we have adding here 20. We have adding here 10. And here we have no need to add 0 in the third part because it's already the 3 digits. Got it? Understood? Any confusion?
Yeah.
So unlike decimal, you can convert it into the like decimal easily if you are adding 0 to the extreme right of the decimal part because it does not change the value of the decimal number. Understood?
Yeah.
So any number you can change it accordingly. Suppose I am giving one more example like this. So that because this will work in comparison of decimal also, okay? So it's very important. So question is 11.1070. The other part is 1.1107 and the other part is, sorry, this is not 0, 11.107, 1.1107 and the other is 11.1060. Check the highest number of decimal place. Here is 3, here is 4, here is 4. So we have two decimal numbers which is 4 decimal places, but here is only 3. So you can convert it into the like decimal as others because others are 4 decimal places, but in the first one we have only 3. So we have given 0 in the extreme right and it will become a like decimal. Understood the concept? Yes? Any confusion here? Tell me fast.
No.
Now try to understand the comparison of decimal with the examples, okay? Then you will understand perfectly. Suppose the question is 348.02 and the other side is 97.85. So you know what is the first rule of the comparison? When comparing two decimals, first compare the whole part, okay, and then the
Yeah.
fractional part, or you can say that the decimal part, okay. So first of all you will check the whole part, both the side. Which part is greater? Definitely 348 is greater than the 95, so this whole side is greater than the other side, isn't it?
Yeah.
Suppose the question is 69.1 and 69.4. Now see, in this, first of all we will compare the whole part, okay. When the whole part, the decimal with the greater whole part is the bigger, as we have done in the first question. Second is, if the whole part are equal, so the decimal with larger digit in the tens place is bigger. So now check, if see, this part is equal, 69, 69, whole part is equal. So you will move to the decimal part. So decimal part is 1 and 4. Definitely 4 is greater than the 1. So this is the greater one. Understood? Yeah? Now the third comparison. Suppose 8.275 and the 8.239. See, 239. Now which is greater? So first of all we will check the whole part. Yeah, here whole part is same. Now move to the decimal part. So decimal part you will check the tenths place. Tenths place is again same, 2 is also same, but yes, hundredths place is different. See, here is 7, here is 3. So which is greater, 3 or 7? Which is greater?
7.
7.
7.
So definitely this will be a greater than other. Understood the concept? So check one by one step, okay, because these are the easy number. When I will give you the millions, billions and like the big numbers, we'll learn in the exponents.
I thought there was no billions or millions.
256 point, suppose 256.7 and the other side is 256.70. Now check which is the greater one. First you will check the whole number. So yes, we can see it, whole number is same, right? Now we'll move to the decimal place. So when we move to the decimal place, as we have learned just equivalent decimal. What is the meaning of equivalent? Equal value. When you adding 0 in the extreme right, there will be no change in the value. So I can add the 0 here. Now check which is greater. Anyone is greater? Anyone is greater in the fourth or same?
Same.
Same, because 7 is same and this 0 we can add it because this was the unlike decimal. So I convert it into the like first and then compare it. So it will be easy. Now the last example I am giving you, 15.468 in the left hand side and the right hand side is 15.465. Now we'll check the first. As I told you, you will check always the whole number. 15 is same. Oh. Now move to the decimal part. So decimal part, 10th digit is also same. Then 100th place is also same. Now check the 1000th place. 8 and 5. Which is greater? 8 is greater. So the whole number is greater than the other one. The whole number is greater than the other one. Any confusion in the comparison? Now you can do it. Yes or no?
Ma'am?
Yeah.
I just got muted. Did you mute?
First rule of the comparison is when comparing two decimals, first compare the whole part. If whole part, then the decimal part. Okay. If the decimal with the greater whole part is the bigger, like a first question, because it's a whole part, the whole part is greater than this part, so this will be the greater value. If the whole part are equal in decimal, like in this question, so you can check with the decimal part in the tenths place is bigger, like 4 and 1 both are is at tenths place, so 4 is bigger than 1, so the whole decimal number will be greater than this decimal number. If the whole part is same, the tenths place is same, so you will check with the hundreds place. So here 100 place is 7, here 100 place is 3. Definitely 7 is greater than the 3, so the whole decimal value is greater than this value. Understood? This is the third rule. Fourth is, if there is a both the side, you will see there is a whole part is same, tenths part is same, but it's unlike decimal. So you can add 0 as much as required and then compare it easily. So when we give 0 here, then we can see it both the side exactly the same value, exactly the same numbers. So it's a equal. There is no bigger than other. Now the fifth is check the whole part, then tenths place. If tenths place is also same, then move to the hundredths place. This is also same. Now move to the thousandths place. Now we got thousandths place. There is a two different number, 8 and 5. So of course 8 is greater than the 5. So the whole decimal number is greater than this other number. Understood the concept?